Welcome, everybody. We will be starting in just a moment. So give it about a minute and we will get started in today's class. Thanks, everyone, for joining in today. Be going live in just a moment. Welcome, everybody. I'm JR, Director of Technical Development here at Hero Appliance Academy, and we're going to be going over kind of a part two to what we originally talked about on the basic wiring schematic. So before we get into all that, we are going to be introducing a new segment. This is going to be called the Tool of the Month. And this month, we're going to be highlighting the Klein Tools mini ratchet. Hopefully, y'all can see this mini ratchet right here. It's 1/4 inch on one side, 5/16 on the other. You even have a slot here for you to put your finger so you can get some proper leverage. It does have a lever right here to be able to switch from left to right drive, and also you can use your finger to be able to drive it here. And the cool part about this ratchet, of course, being small, you can get into some tight places. It's magnetic and it has a pass-through. Now the pass-through isn't that great, kind of small pass-through, but it does have it. And like I said, it's magnetic on both sides. So if you order this one, it's part number 65200. Hopefully y'all can see it. And we can throw it up there, the numbers on there, the 65200. And if you order this one, it does come with a bit set. You get a number 1, number 2 Phillips, a 3/16 and 1/4 inch flathead, and a 1/4 inch drive. And kind of just show you guys here the 1/4 inch drive. And that lets you put a 1/4 inch drive and do a 1/4 inch socket attachment to the mini ratchet. Just a nice addition that Klein does for their tools. Really just been blown away by what Klein's been doing here recently with their tool setup. There's two ways you can get this tool, the 65200, or you can do, I want to say, can't remember the other part number off the top of my head, but you should be able to see it on your screen here in just a moment. But you will have to order it where it comes with the small stubby. Part number is 85515HD. You get the flip socket stubby with the ratchet, and of course you get your bit set. Now this is going to run you close to $34 on Amazon, Home Depot, and things like that. And of course the stubby, you do get flip sockets on the sides. You get 1/4 inch, 5/16, 3/8, 7/16, removable shaft. And in your stubby, you do have extra bits and everything like that. That's if you wanted to go that route. But at the 65200 ratchet, this is going to run you about $15. And kind of just want to show you guys how good this is and, a good use for it. Let's come over here and take a look at this refrigerator. So in those situations where you got to adjust your feet, this ratchet really comes in handy. Yeah, look, again, you got that 1/4 inch and 5/16 drive. You can go 1/4 inch. Make sure we're tight on there. Put it in the right direction and go to town. Again, having that slot where you stick your finger and get that leverage really helps as well. Since it's a small tool, you do have a way to get that leverage. And I mean, that's perfect. Small, compact, really great tool. All right, so going from that, what I want to kind of touch base on the segment we're talking about is if you got any recommendations for some specialty tools that you use that makes your everyday life easier, send us, we do need part numbers. It has to be a tool that can be ordered because we would love to get that feedback. Maybe order the tool ourselves, put it through the test, and see if it makes the tool of the month. So if you have a specialty tool that you use that really helps you on every day, send it to us through our email. We can throw our email up there for you guys to see it. should already be up there. Send it to us through our email. You can comment, leave a comment. You know, we just make sure you give us a part number so we can try to do that, and we'll address it next month if we get some feedback. Otherwise, we do have some other tool of the month coming up very soon. So back to what we're talking about. This is part 2 to our basic wiring schematic class. So today we're going to kind of apply what we've been talking about related to our first class. We're going to go in here on the computer. I'm going to just kind of do a basic quick refresher, and then we're going to apply it to a unit. Now, on the original page, the welcome page, you probably noticed the refrigerator and a washing machine. Well, due to me going into this refrigerator, I actually found more things I want to talk about. So we're not going to be really touching on the washer today. We're going to focus on the refrigerator. We are going to do a part 3 of this series, and we might go into making small series. So the basic wiring schematic will go into a part 3 in 2 weeks. And then we'll do, you know, the washing machine and so forth. But I just want to let you guys know that this is going to be a total series with a part 3 coming. We might do a part 4, but that all depends on how part 3 comes out. So we're going to jump in and kind of go over some of the things we talked about last time. So let's jump in here and I'll kind of go over it with you guys. All right. So what we're going to be looking at today is a WRF 555 refrigerator. This is a very common refrigerator. Some of you might remember the old Maytag Iceland units. Same design. This is the same Maytag Iceland unit design. It's been around for years, and then Whirlpool, of course, acquired Maytag, and now we see these in Whirlpool designs. But these are the refrigerators, and we'll go into it and show you guys the refrigerator itself. But these are French door, bottom mount, WRF 555 with the large ice maker housing on the top left. This is not to be confused with the AK-12 design with the small, low-profile ice maker on the top left. This is the one with the full-size heat-released ice maker on the top left. So let's kind of come in here, and I'm going to get my laser pointer, and we're going to kind of go over some of the basic things we talked about last time as far as symbols and kind of understanding the wiring schematics and wiring diagrams. So what you're looking at right now is the WRF 555, the full wiring diagram. This is not the basic schematic, which is a more simplified version. The reason we're really focusing on the wiring diagram side is we can talk about some of the symbols we talked about last time and addressed last time. So one of the biggest things, and you're going to see this on the actual unit as we apply what we're talking about to the unit itself, is talking about this symbol right here. Let me switch to my pen. Let me get my pen right here. All right. This symbol right here. This is really important when dealing with the refrigerators. This symbol is the most misunderstood symbol and the most important symbol, really, when looking on the diagram side of things, is trying to understand what this is. I would love to get some feedback from you guys. If y'all can comment, if any of y'all remember what is this symbol called, what does it represent when you're looking at it on a diagram. Feel free to comment. I'm going to give y'all a couple of minutes before we move on. But if y'all can remember from the first class, what is that symbol? What does it mean? Type your answers in the comments section before we get started here. Anybody remember what these were? We talked about them in last class. All right, if y'all don't remember, this is knowing when you're coming in and out of the liner. So when you're looking at a diagram and a schematic, and usually you only see these on wiring diagrams, not really the schematics, because schematics is more of a simplified version. But when you're looking at a diagram, this lets you know when you're inside the unit or when you're coming out of the unit. So what we're going to do on this model, we're going to focus on the ice maker because we got a WRF 555, with the complaint being on this unit is the ice maker works, but it won't fill with water. Won't fill with water, and that's our complaint. So we're really going to focus, and like I said, to kind of keep yourself from being overwhelmed when you're looking at this whole entire diagram, is just focus on the area that you're working on. We know our complaint, our ice maker works, but we get no water to our ice maker. So our ice maker is right here. Our water valve is right here. And I know this is really, really blown out and you guys probably can't see it. And we're going to zoom in. But the reason I'm bringing this up is because we really want to be able to just focus on what we're working on, our load of interest. We don't want to have, anxiety when we're looking at all this and thinking about everything else on this diagram. Let's not worry about it. Let's kind of erase this from our minds. We're not focused on any of this extra nonsense. We are focusing only on our load of interest, which is going to be between our ice maker and our water valve. So everything on the diagram can pretty much just be gone. So let's go ahead and zoom in here. And this is where we're zoomed in. Same diagram, but we're really just pointing out our ice maker. And let me highlight right here. Here's our ice maker. Here's our water valve. That's the two things we need to worry about. So we're only going to trace that circuit out to kind of understand what's going on. And most guys in this situation would, I got an ice maker, it's working, but there's no water coming from my water valve. I'm going to go ahead and replace my water valve. And here in a moment, when we actually get into the unit, we're kind of going to understand why a lot of guys do this. And we'll go over that here in a second. But there's certain situations where you replace the water valve and you still can't get water. What's going on? And that's when really understanding a wire diagram can save you, because what I'm going to show you on this unit is actually a very common failure, something I ran into when I worked at Whirlpool Tech Line. I've had a couple of guys at the company I'm working at right now, S&S Appliance, where they've called in and had the same issue. And it's something that a lot of guys miss just because you miss that opportunity of knowing how to read a diagram. You really miss this diagnosis. So I'm going to go ahead and show you guys what the circuit looks like traced out. So here's our full circuit. So I'm using blue as our main line power. Now, of course, I got this zoomed in, so you can't trace this blue all the way to your source. But here's our blue. This is our power going into our ice maker. I'm using yellow as our neutral to highlight the neutral side of the circuit. And it does everything. The common and neutral wire, they splice throughout this model several times. So really, I'm not going to zoom in to show you guys exactly where the source is, but really everything is coming from the control when we're looking at this model. Then we have green for our ground. That's going to our ice maker. And then I'm using pink for our output voltage from our ice maker. So if you have basic knowledge on how these heat release ice makers work, or the twist tray ice makers, is basically you do have an input power into your ice maker, and you have an output power from your ice maker to power a water valve. 9 out of 10 times your water valve is operated by the ice maker itself, and that's what you're seeing right here. If we follow through on this pink wire, this will be our L1 coming out of our ice maker to our water valve, and you can see it. Let me get my highlighter just to get my laser pointer. Here we go. You can kind of follow it through, and you can see that it's going in and out of the cabinet through hidden connectors to our water valve. And you can tell that that water valve is not getting a source of power from anywhere else except the ice maker. And that's on this model. There's different models that operate differently, but for the heat release and some of the twist tray ice makers, power is supplied to a water valve directly from the ice maker. So just want to make sure you guys understand this color coding. Again, blue is going to be L1 to our ice maker. green is going to be our ground, yellow is going to be our neutral, and pink is going to be our output to our water valve. So I went ahead and tested this unit, and I ran the ice maker. Ice maker ran great. Never got any power to my water valve. Nothing there. And usually what I see is, guys, well, you replace this water valve, it didn't work, well, then I'm replacing my ice maker. That doesn't work. I'm replacing a control board. For some reason, some guys will go to a control board. That doesn't work. And at that point, I'm calling tech support because I can't figure out where I'm losing power. And this is where it's really good to understand schematics, is to understand hidden connectors. This right here, this 8-pin connector is actually hidden. It's not something that you're going to be able to just get to easily. It's not sitting there looking at you when you open the refrigerator door. This is actually hidden, but a lot of guys miss it because, well, you don't understand how to read the road signs of what the schematic is trying to tell you. What we talked about in the last class is understanding what all the wording means around the schematic. What is the schematic telling you? Well, this diagram right here, as you can see, it's telling me where I am. These little dotted lines, this little box right here, these are pretty much sections of this refrigerator, and it's telling me where I am on the diagram. Let me erase some of this and get it all out of the way. So let's say I'm trying to find this hidden connector. And believe me, this was a call I got recently, and a lot of is, where is this connector? I can't find it. I've looked everywhere in this refrigerator. I can't find this connector. Well, if you look at the box, where is everything that's inside this box? It's telling me right here. It's inside the RC light housing module. So it's hidden behind the RC LED module. And just that little bit of information that we miss will put us in a different path as far as trying to figure out where this connector is. Without understanding what you're looking at, and you can even see it on this side right here, it tells me that everything on this side of the box is my ice box module. So everything over there, my ice maker, is going to be where this 16-pin connector is going to be. So understanding what all this, engineers put all this writing and all this information out here for a reason. That's to get your attention. That's to let you know where things are. If you don't read this information, you're not going to know how to travel through. Like I said before, it's like reading the GPS and learning how to drive. You know, you kind of have to understand how this stuff works. Otherwise, you're not going to be able to get behind the wheel of a car and drive it from point A to point B. That's going to be the same thing with the diagram and the wiring schematic. So understanding what these little key words are and what they're trying to tell you is going to be extremely helpful. So we're going to talk about how to test power to this water valve using this diagram and how we can figure out where things are. We might have some back and forth between this image that you're looking at here and also on the unit. So we're going to get into that. We're really going to show you guys how to get to all these hidden connectors. So let's go over to this unit itself. Again, this is the WRF 555 French door bottom mount refrigerator. And I already got the shelves pulled out. This is a very typical Maytag Iceland unit. You've probably seen it, for years. Maytag, Whirlpool, you've seen the Iceland unit. There's been some key changes, and we're going to talk about one of the key changes that might be giving you a headache when it comes to testing these units. But the first thing I want to show you guys is something I got feedback on. Let's take a look at this side, and it's going to be how to remove this little cover right here so you can actually pull the ice maker. I'm just kind of going off topic just to show you guys really what's happening here. I use a very small flathead screwdriver. You can use a stubby, anything that's really going to be able to get in here. And what you're doing is you're going to find a little clip. What I like to do is get underneath the clip. And you see I'm underneath it. My screwdriver isn't moving. I'm underneath the clip. Once I find my clip, then I just go right above it push down, and my cover comes off. And what you're doing is you're coming through this side, you're applying pressure on this clip, and you're pushing it down. And what you're doing, if you want to get up here, what you're doing is you're releasing it from this tab. So when you slide this clip over, it kind of rides this track until it clips right here. And what you're doing is you're pushing down on that clip, right back to what we said right here. You're pushing down on this clip. I'm going to show this clip right here. You're really pushing down on this clip. That's what you're doing. That's how you take this cover off. Now, you are doing this blind. It's a little tricky. That's why I say I usually stick mine in there and kind of find the bottom. Once I find the bottom, then I can go right above it and just push down on it, because you might be in there just going all over the place trying to find that clip. So that's just the tip that I'd use that helps me get in and out of that. And then to put it back in, you're going to, again, just ride that track till it clips in place. All right, so let's talk about that hidden connector. We saw what the diagram was telling us. It's with the light module. Believe it or not, on the Iceland units, your RC thermistors also always in the light housing. I've had techs call me, hey, I've looked all over in the walls. Where's my thermistor? It's in the light housing. If you look at your diagram, you will see the thermistor is on that light housing. So how do you take this light housing down? There's been several variations of this light housing. The newest one is, of course, LED. The older ones had a screw in the back. Some of them had just two double, standard light bulbs. There's a little clip on the back here, and I'm going to use my little flathead screwdriver, get behind the clip, and just pry it down and pull the housing down. And what you're doing is you're kind of getting, there's this clip right here, and you're trying to, and you can see all the marks I've made, in the past when I was taking this unit's been taken apart several times. You kind of go in there. Again, you can use a flathead screwdriver like this. If you don't want to leave marks on the plastic, I would recommend using kind of like a car detail kit, something of that nature where it's plastic and you might not leave a mark on that. But again, it is hidden, so you have that as well. Now you have 4 points here, 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 and here where there's hidden tabs. What you're going to do is go into the tab, feel where the tab is, and you're going to push that way. You're going to pretty much push against it. So I'm pushing my screwdriver to my right-hand side so the head of my screwdriver can go to the left. And then I'm kind of just pry down on it. And it is tight. I will tell y'all it is really tight. There we go. Now that I got it down, I can kind of have my screwdriver in here to show you guys. You put your screwdriver in and kind of push it away from the refrigerator, these tabs right here. So you're just pushing on the tab like that. That's what's going to drop. You got 2 tabs, and I do take it back. I said you had 2 tabs in the back. You really don't. You just have the 2 supports in the back there. Again, here's our thermistor. If I needed to replace this thermistor, it is hardwired in. It would have to be cut out. And Whirlpool provides a thermistor kit that you would put a wire nut and wire nut it in place. So you're going to have to hardwire it in. All right, so right here, now we have access to everything. As you can see, we have that hidden connector. That is where this connector's always been. And again, without seeing it on the wiring diagram and where it was kind of showing me, you might not actually see it. So let me go ahead and just silence this door real quick. All right. So without understanding that diagram, you might miss the fact that you have a hidden connector here. So when you're checking power, it's not always about checking at the load. You might need to backtrack from the ice maker through a hidden connector to the valve. You might have a loose connection. You might have a broken wire. You might have, other things that's happening. So we're going to go into the valve area here. So to get to the water valve, I'm going to pull this cover off. Again, you're just kind of bending it and getting it off the clips. Once you get that off, you have these clips here. Again, same style clips as the light housing. You're just pushing down on the connector, We have that main well down, and then we have one more here, and then this comes down, and there's our water valve. Well, what you might be seeing is the headache that I've been kind of wanting to point out, and unfortunately, this is where manufacturers are going, and not something I agree with. It makes things difficult, and I kind of understand why some technicians might go into being a parts changers because of this, because I've tried checking power to this valve, and in its current state, it's physically impossible. Even with needle nose, whatever it may be, you are not getting in there to check power. That's just not going to happen. I've tried every possible way, and there's no way to check power in its current state. And of course, when you're checking power, you always want to do it under load. So some guys might say, okay, well, I'll unplug it and I can check power and my exposed pins. The problem with that is that you're no longer under load, and you can get a false positive that way. So when you're checking power, you always want to do it with the wire plugged into the load to see if you have a voltage drop due to your source of power being weak and not handling the load. I can't begin to tell you how many times I've checked power to something, have 120 volts, but as soon as I plug in, my source can't handle the load and I drop down to zero. Which would then, in the situation like this, would be a control issue as long as my power source to my unit is okay. But can't check power to that. But what you can do, this is not recommended by the manufacturer or anything like that, but unfortunately, based on what the manufacturers are providing us as test points, I have no choice but to come in here and pretty much take this little cover off, which is the retainer for the power clip, exposing my 2 pins on my valve, which I then can plug back into my pins. And it's not a secure connection. Let me just tell you guys, it is not secured. This thing can come right off. It is not secured at all. But that is going to be the only physical way that I'm going to have test points that I can put my leads to and check power to my water valve. I have seen this on the newer side-by-sides, Whirlpool units, KitchenAid units, everything that Whirlpool's manufacturing right now. Other manufacturers are doing it too. They're going to these smaller retaining clips, which is great for them, terrible for us. We cannot check power. And let me tell you, this is a very simple component. We've checked power to water valves thousands of times. We should be able to check power to a water valve. Manufacturers are making it difficult for us, so you have to kind of find a way to do it. Unfortunately, the only way to do it is you're going to have to remove this little clip off of the valve to be able to expose the pin so you can have a test point for your meter. Otherwise, your meter, even with needle leads, it's not going in. There's no way you can get in this connector at all to be able to check power to it. I've tried every possible way, back pronging, front pronging, through the wire, everything. It just doesn't work. This was the only way that I can actually physically check power to the water valve was doing it this way. And unfortunately, that is a bad point. And we're kind of going to show you guys. You've probably seen this. Let's show you guys what the old water valves used to look like. So what you're looking at the old water valve. This was, again, the same Iceland unit, Maytag Iceland unit. The old water valve had 4 points that you can check power to. You can back prong it from the top, as you can see it there on the picture, and where it's red circles. And then you can prong it on the bottom where there's actually 2 cutouts that you can go with your meter leads. Or you can even slide the connector slightly, lift it up just slightly to expose the prongs on the water valve solenoid, and you can actually check power that way. Those, when I was in the field, that's the water valves we had. That was the water valve you guys are probably most familiar with. This is the same, believe it or not, it's the same water valve. It's just different connectors that they're putting on the solenoids. But as you can see, there's several points there that I can make a good connection and check power to a water valve. That's how every single unit should be. It should be accessible to a technician to make those connections. But if we go back and look at it here, this is just terrible. I'm not gonna lie. I'm not trying to, sugarcoat it. This is absolutely atrocious. This is horrible. It's difficult for a technician to make checks to that, and especially to something so simple like a water valve. So unfortunately, that's the only way to make a proper voltage check to very simple components that we've been checking power to for several years. Things have changed a little bit. So we can either complain about it or we can adapt. And as technicians, we should adapt because things are not going to change. The manufacturer is not going to change this just for our liking. They're already changing it for their liking because it might be cheaper. It's probably, you do have a strong retainer there, so it's a more secure connection. And I get that. So as technicians, we need to find ways to properly make checks. And unfortunately, the only proper way to do it is you have to take that retaining clip off. So when I was checking power here, couldn't find anything. Wasn't getting power here. I was getting power at my ice maker right here, and I was checking it right here at the 16-pin connector. So I knew from point A to point B, I had something that was missing. So if we can go back to the highlights, if we look at the highlights right here, you can see that 8-pin hidden connector. And that's where I went next. And if you look at it, you have a tan wire to a violet wire on that 8-pin connector, which supplies power to my water valve. So when I found this connector, if we go back right here to this connector, when I started looking at it, and let me disconnect it here. Here's that tan wire. We're going from tan right here on my 3rd pin to my 3rd pin right here on my valve. And when I looked at it, and I don't know if you can get a good shot of that, but when I looked at it, I saw 2 pins, but I didn't see a 3rd. When I looked on the back side of it, there's my wire, and when I just barely tugged on it, my wire came out. So my wire wasn't even pushed into the connector, and this is pretty much an almost brand new unit, which I believe this was probably the issue with the ice maker. This connector was just happened to be pushed out. It wasn't pushed in all the way into the connection, and that's where I was losing power. Again, I've seen techs replace water valves, control boards, ice makers for this. But reading that diagram, I was able to follow my circuit all the way through a hidden connector behind the light, which you would never think for a water valve, for your ice maker, that you're going to have a loose connection on a hidden connector. But sure enough, when I found it, it was in there, but it was barely pushed through, and I didn't even notice it until I actually looked inside my plug and noticed that one of my pins was actually missing. And that's when I started tugging on wires, and the purple one just came right out. So again, that is why we look at schematics. We do these for a reason, so we can actually properly diagnose these units. And that's why it's important to read that diagram and follow your circuits all the way through and understand where things are, because manufacturers are going to unfortunately hide some connectors from you. And that's just, you might not have the space in the cabinet where that connector is rarely accessible. They might have to hide it, but they do tell you in the diagram. So it's important to understand and read the diagram. I'm not going to bother fixing it because honestly, this is a good bug unit, and I'm going to leave it that way for technicians to come through in the future to be able to diagnose this unit. And this is a good bug, so I'm going to leave it this way, leave it bugged for future trainees to kind of diagnose this ice maker issue. But let's go ahead and put everything back. Again, you're going to slide it into your slots here. Going to plug in our light. We're going to put our thermistor into its housing. This is our fresh food thermistor. All right, and we're going to just give it a little love tap. And let's put our light cover back on. All right, we're going to put our panels back on here. Put our wall. Again, everything is just pressure fitted. And when it comes to the filter housing cover, I like to just come in on one side, kind of come in through the other, snap it in place, and there we go. Now, if I was in a customer's home, this would have been a first call complete. Connector back in, push it in. Again, only going to be able to diagnose that with knowledge of reading a diagram. So let's come over here back to the diagram. Let's go back to my computer here, and I'm just kind of do a basic review of what we looked at. Again, right here, this is that violet wire. This is what was pulled out. It had backed out of that connector. An ice maker water valve connector hidden behind an RC module. If y'all hearing any background noise, I do apologize. We are getting some rain here. All right. So, again, not something you would typically see, but again, understanding where hidden connectors are and understanding how to read this schematic and trace your flow of electrical in the circuit all the way back, you'll be able to find out where it is. You know, and sometimes it could be a broken wire. Sometimes it could be a broken wire in the cabinet. Could be a bad connection in the cabinet, whatever it may be. Again, not something you're going to be able to diagnose without understanding how to read a diagram. So again, this is why understanding and reading diagrams are so important. Again, we're going to do a part 3 on schematics and diagrams. Next is going to be applying everything we talked about, but we're going to apply it to dryers, timer contacts on dryers, and understanding the backfeed voltage. There was just a lot more going on with this refrigerator when it came to the circuit. Again, just looking at it, you can kind of see how everything is ran here. Again, blue is our L1 side of line. We have green for our ground. We have yellow for our common, our neutral, and then we have that pink purple color that I'm using for our output voltage to our water valve. All right. So just kind of covering what we talked about here, understanding why it's important to read a diagram. We're going to go into a little bit more in part 3 of this series, where we're actually going to apply it to a dryer and understanding the contacts on the timer and how it flows through switches and everything like that. And we're going to be looking at some bug units there as well. But this was just a very basic look into a very common failure. And if you haven't ran into this issue, I'm surprised, because like I said, when I was on TechLine, I ran into several of these where there was connection issues behind that LED. And by the time we would get that call, water valves, control boards, ice makers, they all have been replaced. We're probably looking at 4 trips to a customer's home at that point. This would have been a first call complete if we look at our diagram, use our meter, check to see where our voltage is and isn't. So we're going to go ahead and open up for some Q&A. It could be anything. It could be about the tool of the month. We talk about what we covered here today, what you guys want to see in future classes. Again, part 3 is going to be up in 2 weeks. I believe it's going to be the 8th. Yep, you should see it right there. It is going to be on next training Thursday, August the 8th is going to be part 3. We're going to be looking at dryers using what we talked about in diagrams and schematics. Going to be applying that to a dryer. So any questions? Anything do we have? Going to give y'all a little bit longer here. Again, it could be about anything you guys got a question about. Could be related to today's topic or anything you guys want to see in the near future. Let us know. You can also send us an email if you think about it later on. You can shoot us an email to our email here at Hero Appliance Academy. Also, you can leave comments on our YouTube channel. We do have some upcoming social media. We recently opened up our TikTok. We will have Instagram coming up, and of course our Facebook. You might already be seeing some of the shorts on our YouTube channel that we're doing as we're renovating the warehouse, getting some things done in the warehouse, as we're upgrading. You might be seeing some of that. We do have some future classes coming up, so we'll be having some footage of that as well. And we see our moderators posting some comments there, so feel free to reply. Going to give y'all guys a couple more minutes, and then we are gonna cut it out. I do want to say thank you to everyone joining on StreamYard and, of course, our YouTube. We do have our 600 class coming up. Can you do the 4-door units? 4-door units, which, are you talking about the quad doors? Are you talking about quad doors, or are you talking about bottom mounts? Let's see what we're talking about. Yes, the quad doors. Actually, we have two. We have a bugged one for upcoming classes, and we have a fully functional quad door. We do have some quad doors, and we can do what we want to know from you guys. What do you want to see on that quad door? Do you want to see a tear down? Do you want to see a failure that you guys are typically running into? I know for a fact one of the common failures on the quad door has been the internal RC overhead lights. There have been some issues with those. So if that's, we just need, if you want to do something on the quad door, just need to know what you're looking for in that quad door. What exactly are you looking for as far as training when it comes to that quad door? Just let us know exactly what you're looking for, and we will make it happen. And again, we are going to be hosting and having our 600A refrigeration classes here soon. I believe we have some in August coming up. We do have some more information. All right, we got something from Rick Box. Sora ran into the same situation on a microwave. Fan on the microwave was working on high speed, but not on low speed. And and I know you said you ran into something related to it. So I think it was probably like a loose wire or a bad connection, and kind of had to go through your diagram and kind of trace out your circuit and see what it's going on. I'm taking that. You said you had something related to that, so I'm picking up. I'm suspecting that. Looks like he said found wire out of the connector. Yeah, that's exactly what we're seeing here. That is a common thing, especially on new units. This is something you're going to see right away. Customers are going to report this right away. This is not typically something I see on a year-old, 2-year-old unit, 3, 5, whatever it may be. We usually catch these, pretty fast into the life of the unit. Usually within the first 30 days is where we're. So if I'm coming to a unit and it's 30 days old and I have a load that's not working, first place I'm going to look is probably going to be a bad connection. Something the factory might have forgot. I've even had brand new units where the defrost heater wasn't even plugged in. It was still wrapped up in factory tape, and it was just tucked away in there. And look, manufacturers make mistakes too. So on brand new units, when we have a load failure, that's usually what I'm looking at. So that's a good one. The tear down on the quad doors. Yes, we can do a full tear down on the quad door, especially the freezer side. The freezer side is an absolute nightmare. I've done a full tear down for a training class once, and let me tell you, replacing the evaporator fan on a quad door is probably one of the hardest things I've done as far as appliance repair goes. I couldn't believe it. A simple, evaporator fan job should probably take you 15, 20 minutes. Took 4 guys an hour because it took, every bit of 2 sets of hands to be able to pry open this panel to be able to pull the fan out. So yeah, I would love to show that to you guys. So yes, we can do that. We'll add that to agenda. Probably be after we look at part 3 and potentially a part 4 of our diagram, and we will get into the quad doors. And then from there, we would like to go into some laundry products and dish products for sure. Definitely want to do some dish products. Any more questions before we log off for today? Again, I want to thank everybody tuning in through StreamYard and everyone at YouTube. Don't forget to like and subscribe to our YouTube channel. Keep up to date when we are going to go live. Yeah, we got our handle up there for you guys to see. Got something else? All right, since you showed us what I consider is a shoebox ice maker, talk about what? I think it might have cut you off there or something. It just says talk about. Rick, if you can elaborate there on that one. Just waiting on the response on that one, then we will wrap it up for today. Nothing. Okay. Oh, I think something just popped up. How important it is to make sure the ice maker has to be leveled. Yes, on these units, these refrigerators, they're very sensitive to the ice size, the size of the ice cube. Actually had a tech call in yesterday. I want to say it was yesterday. When the customer was dispensing ice, they were getting a mix between crushed and cubed. The solenoid was perfectly operational. The actual ice container itself, the ice box, there was nothing wrong with the moving parts, the crushing teeth, the crushing door. Everything was fully operational, but he was dealing with a mix of crushed and cubed ice, and thought it was a failure. And another thing that can happen is also jams on that ice. The ice maker can jam. You can have some issues there as well. And what's happening is if the refrigerator is leaning forward, that ice mold is filling up with water, and all that water is coming to the face of the ice maker. So you're going to have large cubes in the front and small cubes in the back. And what that's going to cause is those larger cubes, the ice maker just, for one, might have an issue as far as dispensing that ice or ejecting that ice. It can cause the ice maker to jam. Or in that case yesterday, the large cubes were actually being crushed because they were too large to be properly dispensed, and it was causing the crush effect that the customer was dealing with. A proper fix, just level the unit. All you got to do is put a level on top of the unit. You want to do, always, when you're checking the level, you want to come to the lip of the cabinet from left to right on the lip. Never do in the middle of the unit, because all refrigerators kind of have a bow to the top of the refrigerator. So you always want to check your level at the front lip, left to right, and then, of course, across your sides from front to back, always on the lip of the cabinet. And then that's when your tool of the month comes in hand, and you adjust the feet, level that refrigerator, and you won't have an issue with that ice maker again. Next training, Thursday, August 8th. And we're going to go ahead and call it a day, and thank everyone for joining us today. Unless we got any more comments, if we don't have anything, we will let everyone go. Again, thanks you guys for tuning in, joining our live. Don't forget to subscribe to our YouTube channel and keep an eye out for other social media platforms that will be opening up here soon. So have a good day.